atom is no overall charge, and the positive charges of the protons completely balance with the negative charges of the electrons. So let's go ahead and draw an atom of hydrogen. So we know the atomic number and we're talking about neutral hydrogen. This is a blunt line. It's a very simple view that so this is one version of hydrogen. This is one isotope. This is one version of, and isotopes are atoms of a single element. So we're talking about isotopes that have the number of neutrons. Isotopes are atoms of a single element.
Hey Tiem, just at the right time, bro. Nothing, I'm just struggling with this nucleosynthesis thing that we mentioned in LE. Yeah, I don't understand even a thing, bro.
Oh, I think I got something cool to show you.
Are you sure?
Yeah.
Oh, let's take a look.
Come and check this out.
Oh, are you sure that it's something?
So, stellar nucleosynthesis is a process in a star by which heavier elements are created from lighter elements under high pressure. You'll see how this takes place.
Cool.
Down there, protons or hydrogen cores are represented in red. 4 protons can form a helium-4 core, a process called hydrogen fusion. 2 of the protons then become neutrons, represented in blue. 2 helium-4 cores are fused to create beryllium-A. This can react with another helium core to form a carbon-12 atom.
Now I understand this.
In a heavier star, the carbon-12 atom can end up in the CNO cycle, with slightly heavier atoms like carbon-13 are formed. And carbon-13 is an important isotope.
Wow. This nucleosynthesis thing was just so amazing.
I know, right?
But you mentioned something about carbon isotopes? What's that?
An isotope? I know a guy who can help with isotopes.
No kidding, let's go. Can't wait to see this.
Hey,
hello,
Ricardo Diaz.
How are you?
I got a guy for you here, and he doesn't understand anything about isotopes.
Well,
so
then I guess you're in the right place.
could you help
Thank
guy?
you.
Today we'll be learning about isotopes. You see, all matter consists of atoms. Atoms have a nucleus that consists of protons and neutrons. The amount of protons defines the atomic number of an element, which indicates the element itself. The amount of protons plus the amount of neutrons is the mass number of an atom. Different atoms of the same element all have the same amount of protons, but the amount of neutrons can vary between them. Atoms with the same amount of protons but a different amount of neutrons is what we call isotopes. One of these is carbon-13, and it can be used to answer important questions about what has happened in the past.
Now that I learned all this about the isotopes, it seems pretty okay, but what is it useful for?
Well, you see, since isotopes have different numbers of neutrons, they also have different mass numbers, and as such different masses. This means that they're going to have different properties, especially when life processes like photosynthesis are involved, because these life processes favor the lighter version of 12C over the heavier version of 13C. We can use these properties to trace events in deep time, such as a great oxygenation and any other event that involved biological processes whatsoever.
Fractionation, oxidation, what's all that?
Well, bear with me for one more second. I think I'll be able to explain this to you pretty soon.
Well, I hope so.
Hi, I'm the Magic Book. Oxygen is an essential gas for the development of more complex life forms. Oxygen was formed by biochemical reactions in early life forms, which left a carbon isotope signal in rocks. This is because carbon-12 is lighter, thus more reactive and preferred in biochemical reactions. If there is a relatively high amount of carbon-13 buried in organic matter, it means that there was more biological activity, which used a lot of carbon-12. By analyzing isotope signals from ancient rocks, we can observe increases and decreases in biochemical activity on Earth. The first oxygen was produced by cyanobacteria. Even though some organisms were killed when oxygen was formed, without oxygen, we could never have existed.
Draw an atom of hydrogen. So we know the atomic number of hydrogen is 1, so there's 1 proton in